Hello everyone, welcome to my YouTube channel. This is Navagirika Bridget. So continuing with the introduction of MLOPs in our project, which is called application, with its application in a layer-wise backward propagation for detecting and reconstructing real faces from fake faces. So that's the outline. We are going to talk about the introduction of MLOPs and its relevance to our project, and so on, how MLOP trends and techniques influence the project, its application of the DevOps, data operations, and difference between heavy and light MLOPs, integration of MLOPs hierarchy of needs and maturity models, strategies to handle data poisoning, data drift, and operationalizing microservices. And then the role of CI is like CI is continuous integration, continuous deployment features. So on the introduction of MLOPs and its relevance to our project, first of all, MLOPs stands for machine learning operations. So these are like basically applications of DevOps. DevOps are like the development operations, principles, and automation concepts to manage data workloads. So it's so relevant to this project because to help us like during the deployment stages, when updating the system, when maintaining a project, and so on. It's also relevant in a way that it efficiently manages the machine learning cycle, like from data collection, data monitoring, implementation, and then the deployment process. And then like how MLP strengths and techniques influence the project. So the discussion of MLP's trends and techniques highlights the importance of understanding business problems and delivering value efficiently, which directly influences the project's approach. This basically gives us a better way of approaching and solving the problems that that we might encounter during the early stages of the project development. And then the identification of heavy and lightweight MLP systems provide insight onto how different techniques and strategies can be applied. So it just gives us that eureka moment, like, oh, this was supposed to be like this. So when you follow that cycle, it gives us that framework, like those steps we need to follow according to some code in the side. Like I think you can sell continuously guides us. And then the different framework used like the Keras, TensorFlow, PyTorch, and so on and so on. And then the application of DevOps, data operations, and difference between the heavy and light MLOps. So the application of the development apps and data, this basically emphasizes collaboration of the goal used automation and continuous improvement and managing data workloads and machine learning operations for timely results. So this basically helps us to manage the results in that results are gotten on time and in a specific period of time. The difference between heavy and lightweight MLOps systems. Further, there are more and more. They continuously elaborate on how these principles are implemented based on the project's need. The project might be needing something like we need this and this. So it's basically going to help us to elaborate more about what the project needs. Like this example of how for an original image, then a reconstructed image. This is the virtual image, and this is the real image. So it gives us that understanding. And then the integration of MLOps hierarchy needs and maturity model. So this hierarchy basically needs in the needs in MLOps is integrated by outlining the bottom to top architecture, like begin from down and you go up. Where here we started with the DevOps, like the development operations we will need, and then you go to the data operations, like to do data jobs and tasks, like things that will need data, and then platform automations. This basically will maybe for hosting the project and all that, and then MLPs for improvement and automation, like continuous improvement. That's where strategies to handle data poisoning, data drifting, and operationalizing microservices. So the discussion on the data poisoning addresses basically the challenges associated with maintaining model, its accuracy and reliability, aligning with the project's focus on detecting real faces from fake. So accuracy, like is it the detected face that is really detected, or it's the fake instead assumed as the real face? So that's it. Reliability, can people rely on it? Is it giving accurate results that people can base on to say that I'm going to use this and this? So strategies to mitigate data poisoning, also such as implementing regular auditing and adhering to the principles of least privilege to minimize access to sensitive data during training and predictions are directly applicable. They also ensure integrity of the project machine learning, like as in the project being altered, no one has changed anything in the project, and so on. And then basically, and last but not least, the role of CI/CD features towards in the importance of Python files used. So for CI/CD, we say it's continuous integration, continuous deployment. These pipelines automate testing, the continuous integration and deployment of model updates, ensuring rapid and reliable delivery of improvement. So that continuous improving, like the project has already been released to be used, but you can continuously deploy and continuously add features to it and so on. And then feature stores centralizes feature management, ensuring consistency and reusability across the face detection and reconstruction. Like several people can access it, someone can use it, this one uses it, another also can detect his face or her face in a different way. Not that once it's used, that is it, to only be detecting that one person's face. No, several people can use it for feature face detections. And then that was basically our reference. Thanks for listening. Good night.